Welcome back to Math on the Fritz with Mr. Fitz. Today we're going to be looking at multiplying radical expressions. And what you're going to see is when we were adding radicals together, they had to be identical in order to put them together. When we're multiplying radicals, they don't have to be identical. So when you see radical 3 and here you see a radical 6, I can combine those. Multiplication is very flexible. Multiplication can happen pretty much no matter what I'm looking at. But you're also going to notice that I have a number outside of the radicals as well. So when we have this situation, what we're going to be doing is doing the numbers on the outside, outside times outside, and then we're going to do the part that's under the radical times the radical. So it's almost going to be like doing two separate problems. The first is to do 2 times 5, which is 10. The second one, because they're both under the radical, is to multiply them under the radical as 18. Now, whenever we do this process, we always want to simplify our radical. I see root 18, but I want to see if there's a pair in that 18 before I say my answer's done. I can divide by 2. That would give me 2 times 9. 9 can split up into 3 times 3, which is a pair. So I have my 3 prime numbers. Those are the ones that I'm interested in. I have a pair of 3, so that 3 has to come out. There's already a 10 on the outside. And then the only thing that's left over that I haven't used yet is that 2, so the 2 is still under the radical. So now I have 3 times 10 is 30. The square root of 2 is just there. So when I go from this, 2 times radical 3 times 5 times radical 6, I do outside times outside, and then inside times inside, and it stays inside. So then I pulled out my pair. There's the 3. I gave a simplified answer, and I'm done. Now the question becomes, what if you're missing one of these components? So this one had a number on the outside in both places and a radical in both places. What if I erased this and I said the first number didn't have a radical at all? It was just a number. So let's say it's 5. And then I grab the next expression, 3 square root of 10. If I'm doing this problem, I'm going to say, well, I have this number by itself. I'm going to treat that as an outside number. So I'm going to do 5 times 3 because they're both just numbers. That's going to give me 15. And then the radical 10 didn't have any other radical component to combine with, so it just stays as radical 10. Now, if we're getting really mathy about the idea and we're trying to think I always want to have a radical there, technically I could have squeezed in a square root of 1, but that's not necessary for you to do. We're just saying that if you had the square root of 1, 1 times 1 is 1. So I'm allowed to just put a square root of 1 there because any number times 1 is itself. Then you could obey the rule, the outside number times the outside number on the outside, the inside times the inside on the inside. So I'm just showing you that square root of 1 could have been written there to satisfy the rule, but in actuality, it's easier for us to just look at this problem and say, multiply these numbers, copy down the radical. So that was your second example. And then the third example, what if your first number had something there like 5 root 10, and then the second number was just a radical. Now I'm looking and I'm seeing that there's 2 radicals, but there's only 1 number. So in this example, I would put the 1 on the outside of the radical so that I could have a number on the outside for both of them and a number on the inside for both of them. Now I'm ready to do the same as before. Outside with outside, multiplication. Inside with inside, also multiplication. Now, I like to, because of who I am, it's just something that I'm used to seeing. When I get this 200, I know that when I make my tree, it's going to come from 10 times 20, because those are the two numbers I use to multiply it together in the first place. So if you're a person that doesn't like to reinvent wheels, you already have the two numbers that multiply to give you that. So I just started my factor tree with those two numbers. It keeps them pretty small. Now I can see this is 2 times 5. I can see that the 20 is 4 times 5. And then I can see that the 4 is 2 times 2. Now, any of you that haven't been working with primes long enough to have memorized the list, your most important ones are 2, 3, 5, and 7. Most of your numbers will be divisible by one of these right off the bat. A favorite is always, if it ends in a 0, you can divide by 10. So that will save you some time when you're doing the division. So we had multiplication. We kept the outside with the outside, the inside with the inside. Once we got that answer, we had to simplify this. It broke down into this string of stuff. I just have to pull out my pairs. So I have a pair of 2. I'm going to pop out a 2. I have a pair of 5. I'm going to pop out a 5. I had a 5 on the outside, so I've got to keep that 5 on the outside. And then the only thing that's left over unpaired out of my primes was this 2. So that 2 is stuck underneath. Now that I've pulled my pairs, I'm just going to write this as a simplified number. 2 times 5 is 10. 10 times 5 is 50. And voila, I've done my problem. So you've seen really all 3 types you can see. You saw when there was a number on the outside and on the inside for both of them. That was the first problem. You saw one where we had just a number and then a number and a radical. And now you've seen one where we had a number and a radical and just a radical. The only other thing you might see is if they're both radical expressions with no numbers on the outside. Sometimes that happens. It's actually a faster and easier version of what we just did. So as I think about it more, probably should have left that 257. You might just have something like the square root of 45 times the square root of 20. Maybe we have something that looks like this. If we do, that's fine. It's just 1's on the outside. So your answer is just going to have 1 on the outside. But then we have 45 times 20, which is pretty big. I have a calculator. I could easily get that to be 900. If you didn't have a calculator, though, and you couldn't figure out what that was, it's not going to hurt you because whatever that number was, it's immediately going to break down into 45 and 20. So you're going to be able to get an answer for it, regardless of whether you knew this was 900 or not. Now, 45 is going to break down into 5 times 9. And 9 is 3 times 3. So I've got all prime numbers here. But 20 is not prime. I erased my list. Sorry about that. 2, 3, 5, 7. I can divide this by 4. And then that's 2 and 2. So I was able to get all that 900 broken down into these pairs. So now I'm looking at it and I'm saying I have a pair of 5. Let's pull that 5 out. Oh, I got a pair of 3. That was nice. And I have a pair of 2. Wow. Look at that. I don't have anything left over. All of my prime numbers just got eaten up. There's nothing here that's I can't use that 9 because it's already been broken down into 3 and 3. There's nothing left under the radical. So I just have a whole number answer, 5 times 3 is 15. 15 times 2 is 30. And I have it. My answer is a whole number of 30. Seems kind of wild that these two numbers, both being never-ending decimals, non-repeating, would come out to a nice clean whole number like that. But I know it's true. You could check it if you wanted with any standard calculator. I guarantee that's what we'll get. Very cool. So you've seen all of the skills and strategies that we have for solving when you're multiplying radical expressions. They don't have to be the same like they did in addition. They can be different. We're still going to have to pull pairs out once we do our multiplication on the outside and on the inside. The inside part is the part that needs to be simplified because it's under the radical. And the radical requires us to pull pairs. So as you go through this, remember you're looking for prime factors. I'll put more on this list right now just for you to have, in case you're watching this on future playback. That'll probably get you through most of what you need. So check for any of those factors, and good luck with your assignment.